and it is redox reactions. Redox reactions. Next module, next chapter, redox reactions. In the 10th standard, you have studied oxidation and reduction reactions. You have studied that addition of oxygen is oxidation, while the removal of oxygen or loss of oxygen is a reduction. The gain of oxygen is a reduction. Loss of oxygen is a oxidation, while the gain of oxygen, that is oxidation. In the 10th standard, you have studied. Gain of oxygen is oxidation, while loss of oxygen, that is reduction. And it is the oxygen concept of oxidation and reduction. When the reduction and oxidation reactions take place simultaneously, the reaction is called a redox reaction. So, in a redox reaction, there is simultaneous reduction and oxidation. That is gain of oxygen and the loss of oxygen. Now let us see the modern concepts of oxidation and reduction. One is based on the gain or loss of electron, and we call it as the electronic concept of oxidation and reduction. So let us begin with the electronic concept. The electronic concept of redox reactions. Electronic concept of redox reactions. Let us see what it is. You know, during chemical reactions, in some cases there is loss of electron. There is removal of electron. And the change in which there is loss of electron or a removal of electron, that's called oxidation. That is the electronic concept of oxidation. So oxidation means the loss of electron. Loss of electron, that's called oxidation. Or a removal of electron, that's called oxidation. While reduction, that is gain of electron, that is called a reduction. So reduction is the gain of electron or addition of electron. That's called reduction. Say, oxidation is the loss of electron from a substance, from an atom or an ion or any species. Loss of electron is called oxidation. Or a removal of electron, that's called oxidation. While reduction is the gain of electron or addition of electron, that's called reduction. If there is reduction and oxidation simultaneously, then it is called a redox reaction. That means the gain and the loss of electron take place simultaneously. Then it is called a redox reaction. There is a loss of electron as well as gain of electron together during a reaction. Then it is called a redox reaction. And we have two more terms. That is Oxidizing agent and reducing agent. Two more terms. Oxidizing agent. Oxidizing agent and reducing agent. So what is an oxidizing agent? What is a reducing agent? Reducing agent. Okay. So oxidizing agent is the substance that accepts electron. That accepts electron. That is the oxidizing agent. So we can define oxidizing agent as electron acceptor. It is an electron acceptor. Electron acceptor is the oxidizing agent. When the oxidizing agent accepts electron, it is reduced because gain of electron is reduction. So the oxidizing agent gets reduced. So it gets the oxidizing agent gets reduced. It gets reduced. Now you come to the reducing agent. Reducing agent is a substance that gives electron, that donates electron. So reducing agent is electron donor. Electron donor, that is the reducing agent. When electron is removed from a substance, it gets oxidized. It gets oxidized. So let us see the terms again. The electronic concept of oxidation and reduction. The electronic concept of redox reactions. Oxidation is the loss of electron from a substance. Reduction is the gain of electron to a substance. Now you come to the oxidizing agent and the reducing agent. Oxidizing agent is electron acceptor. Electron acceptor. When electron is accepted, the oxidizing agent gets reduced. When the oxidizing agent accepts electron, the oxidizing agent gets reduced. Then reducing agent. Reducing agent is the electron donor, the substance that gives electron. Electron donor is the reducing agent. When electron is donated from the reducing agent, then it gets oxidized. So the reducing agent gets oxidized. Got it? Clear? Say oxidation, loss of electron or a removal of electron. Reduction, gain of electron or addition of electron. Oxidizing agent, electron accepted, which gets reduced. Reducing agent, electron donor, which gets oxidized. Now let us see some examples for this. You take the reaction between metallic sodium and chlorine. Take the reaction. Say sodium reacts with chlorine. Chlorine giving sodium chloride. Say NaCl, sodium chloride. Sodium plus chlorine giving sodium chloride. When sodium reacts with chlorine, an electron is removed from sodium and one electron is accepted by the chlorine atom that you studied in the 10th standard when we were dealing with the ionic bond. So sodium becomes Na plus ion and chlorine becomes Cl minus ion. So the reaction can be separated into oxidation and reduction. See here, sodium is converted to Na plus. And during that change, what happens? You say sodium minus one electron, minus one electron. One electron is removed from sodium. Then we get Na plus ion. Na plus ion. When one electron is removed from sodium atom, sodium becomes Na plus ion. So here there is the loss of electron from sodium. From Na, sodium electron is lost. And therefore this change is oxidation. This is the oxidation half reaction. Oxidation half reaction. What do you think of chlorine? Say chlorine 1/2 Cl2, that is equal to chlorine atom. 1/2 Cl2, that's equal to chlorine atom. Plus one electron is added. Then it will become chloride ion, Cl minus ion. The chlorine atom, half Cl2 means chlorine atom. So chlorine atom plus one electron giving Cl minus ion. So chlorine atom, so it gains electron. Electron is added to the chlorine atom, and therefore that reaction is a reduction. That is the reduction half reaction. So from sodium, electron is lost. So it is oxidation. From chlorine to chlorine, electron is added. And so it is a reduction reaction. Reduction is addition of electron or gain of electron. So half Cl2 plus one electron given Cl minus ion, that's the reduction reaction. Now, which is the oxidizing agent and which is the reducing agent? Which is the oxidizing agent? Oxidizing agent is the electron acceptor. Electron acceptor is the oxidizing agent. Here, chlorine accepts electron. Chlorine accepts electron. Electron is added to chlorine, and therefore chlorine is the oxidizing agent. This is the oxidizing agent. Oxidizing agent is chlorine. Chlorine is the oxidizing agent. And what happens to chlorine? When electron is added, chlorine is reduced. It is reduced to chloride ion. So chlorine is reduced to chloride ion. Now come to the other reaction. What is a reducing agent? You know, reducing agent is electron donor. Electron donor is the reducing agent. From sodium, electron is removed. So sodium donates, sodium atom donates electron. Therefore, sodium is the oxidizing agent. This is the oxidizing agent. And it gets, so not the oxidizing agent, it is the reducing agent, sorry. It is the reducing agent. Sodium is the reducing agent. Reducing agent, electron donor. Electron is donated by sodium atom. And therefore, sodium atom is the reducing agent. It is the reducing agent. So when electron is removed from sodium, it gets oxidized. I can show it in another way. Say here there is sodium plus half Cl2 giving Na plus Cl minus sodium chloride. During this change, say the changes are this: sodium is converted to Na plus ion. When sodium is converted to Na plus ion, one electron is removed. Minus, during that change, minus one electron. And therefore, it is oxidation. Electron is removed. It is oxidation. Now, what about the chlorine? Chlorine half Cl2 chlorine atom. That is converted to chloride ion. And during that change, one electron is added, plus one electron, addition of electron. So that change is reduction. The reduction. So chlorine is reduced to chloride ion, while sodium atom is oxidized to Na plus ion. Now, which is the oxidizing agent and which is the reducing agent? Oxidizing agent, that is electron acceptor, which is accepting, which reactant is accepting electron? Chlorine is accepting electron. So chlorine is the oxidizing agent. So this is the oxidizing agent. Chlorine is the oxidizing agent. Say oxidizing agent gets reduced. And which is the reducing agent? Reducing agent is electron donor. Here electron is donated by sodium atom. And so Na, sodium is the reducing agent. It is the reducing agent. And now what happens to the reducing agent? The reducing agent gets oxidized. So Na is the reducing agent and it gets oxidized to Na plus. Chlorine, Cl2, chlorine, that is the oxidizing agent. And it gets reduced to chloride ion, Cl minus ion. So reducing agent gets oxidized and the oxidizing agent gets reduced. Let us take another simple example. See the reaction between zinc and Cu plus 2 ion, copper sulfate. Say there is the formation of a Zn dipositive plus Cu. That is the reaction. Zinc is added into copper sulfate solution. In copper sulfate, there are Cu plus 2 ions. And we are adding zinc into Cu plus 2 ions. Now what happens? So Zn is converted to, say the reaction is this. Zn is converted to Zn plus 2. When Zn is converted to Zn plus 2, two electrons are removed from Zn. So minus 2 electrons. So there is loss of electron from Zn. And so it is oxidation. Zn is oxidized to Zn plus 2 ion. Now you come to the second reaction. That is Cu plus 2 ion is converted to Cu. Cu plus 2 ion is converted to Cu. And during that change, what happens? Cu plus 2 accepts 2 electrons, plus 2 electrons. Then the change is plus electron, additional electron. It is a reduction. So reduction is Cu plus 2 giving Cu. That is a reduction. Cu plus 2 giving Cu. That is a reduction. Cu plus 2 giving Cu plus 2 giving Cu. That is reduction. And which is the oxidizing agent and which is the reducing agent? Oxidizing agent that accepts electron. Oxidizing agent accepts electron. Which reactant is accepting electron? Here Cu plus 2 accepts the electron, and therefore Cu plus 2 is the oxidizing agent. This is the oxidizing agent. Cu plus 2 is the oxidizing agent. And which is a reducing agent? It is electron donor. Electron donor. Which reactant is donating electron? Which reactant is giving electron? Sudden. Sudden is giving electron. And therefore sudden, that is the reducing agent. Sudden is the reducing agent in this reaction. So here there is the loss of electron and the gain of electron together. And this is an example for a redox reaction. There is a gain of electron as well as the loss of electron together simultaneously. And therefore, the reaction is a redox reaction. So, to summarize, the electronic concept of oxidation and reduction. Oxidation is the loss of electron or a removal of electron. Then reduction is the gain of electron or addition of electron. Oxidizing agent, the one that accepts electron, that is electron acceptor. Electron acceptor is the oxidizing agent and it gets reduced. And reducing agent or a reductant. So it is the electron donor. Reducing agent is electron donor and it gets oxidized. Okay. Oxidizing agent is also known as oxidant. It is also known as oxidant. Similarly, the reducing agent is also known as the reductant. The reductant, reducing agent or a reductant, oxidizing agent, oxidant. Do you get this? Do you follow the electronic concept? Now we are not considering the oxygen concept. Addition of oxygen or gain of oxygen, oxidation. Removal of oxygen or a loss of oxygen, reduction. That we have studied in the 10th standard. Now we consider the electronic concepts of oxidation and reduction. That is one method, one concept of oxidation and reduction. We have to see another concept and it is the oxidation number concept. Oxidation number concept. Oxidation number concept of oxidation and reduction or a redox reaction. Oxidation number concept. So, explain oxidation and reduction in terms of oxidation number. First of all, we must know what is meant by oxidation number. What is meant by oxidation number? What is oxidation number? Say, oxidation number is the net positive or negative charge on one atom of the element in its compound or in its ion, if it were considered as an ion. Say, oxidation number is equal to the net positive or negative charge. The net positive or negative charge on one atom of the element. An atom of the element. In the combined state or in the form of its symbol ion. The net positive charge or negative charge on one atom of the element. That's called the oxidation. Say one atom. Say here the net positive or negative charge on one atom of the element. That is called the oxidation number. Okay. So find out the oxidation number of an atom. We must know some rules regarding the oxidation number. Say rule number 1, that is oxidation number of an element in the uncombined state, the elemental state, is equal to 0. Oxidation number in the elemental state, elemental state, that is a uncombined state, is equal to 0. That is a oxidation number of H2, hydrogen in H2, is equal to 0. Oxidation number of chlorine in Cl2 is equal to 0. Oxidation number of Na, sodium atom, is equal to 0. There is no charge. There is no net charge. Oxidation number of Ca, calcium atom, that is equal to 0. Oxidation number of Al, aluminum atom, that is equal to 0. So in the elemental state, that is in the uncombined form, oxidation number of an element is equal to 0. Second, oxidation number of an ion is equal to the charge on the ion. Oxidation number of a simple ion, of an ion, is equal to charge, that is equal to charge on the ion. Charge on the ion. For example, you take, say, chloride ion, Cl minus ion. Then oxidation number of chlorine in chloride is equal to -1. That is the charge, -1. Oxidation number of sodium in Na plus ion, that is equal to +1. Oxidation number of calcium ion, that is equal to +2. You take the alkali metals, sodium, potassium, lithium, sodium, potassium, rubidium, etc. Then the oxidation number in the ionic form, in the combined form, that is equal to 1. Oxidation number of the alkali metals in the combined form, in its compounds, that is equal to +1. Oxidation number, same. Oxidation number of alkali metals, sodium, potassium, alkali metals in its compounds, that is equal to +1. You take sodium in its compound, +1. Potassium in its compound, +1. Not as metal. Oxidation number of sodium in the metallic state, 0. Oxidation number of potassium in the metallic state, that is equal to 0. But in the compound, oxidation number of alkali metals, sodium, potassium, etc. in the compounds, NaCl, KCl, KNO3, NaNO3 compounds. So in the combined form, that is equal to +1. Similarly, you take the alkali earth metals, that is group 2. So alkali metals, group 1. Alkali metals, group 1. In the compounds, +1 oxidation state. Group 2, the oxidation number will be +2. Say calcium, +2 in the compound, +2. Magnesium in its compound, that is equal to +2. Oxidation number is equal to +2. So oxidation number of an ion is equal to charge on the ion. For alkali metals, oxidation number in the compounds in the compounds is equal to 1 plus 1, not simply 1 plus 1. Similarly, the oxidation number of alkaline earth metals, that is equal to plus 2. Calcium, magnesium, etc. that is equal to plus 2. Then halogens, alkali oxidation number is equal to -1. Chloride -1, bromide -1, etc. Oxidation number of some of the elements that are taken. 3. Say oxidation number of a hydrogen in its compounds, is equal to plus 1. Oxidation number of hydrogen in its compounds is equal to plus 1. Alkali metals in its compounds is equal to plus 1. Oxidation number of oxygen in its compounds, some exceptions are there, in its compounds, that is equal to -2. -2. Oxidation number of oxygen in its compounds is equal to -2. Some exceptions are there. Peroxides and F2O are exceptions. We can see it later. Then oxidation number of fluorine, bromine, etc. in its compounds is equal to -1, etc. Okay. Now you come to oxidation number of say a group of atoms existing as an ion. A group of elements existing as ions, that is equal to the sum of oxidation numbers of all the atoms in an ion is equal to charge on the ion. Charge on the ion is equal to charge on the ion. We have, say for example, carbonate, CO3 -2. So the sum of the oxidation numbers is equal to -2. Chromate, CrO4 -2. Sum of the oxidation numbers is equal to -2. So in general, sum of the oxidation numbers of all the atoms in an ion is equal to the charge on the ion. And finally, sum of the oxidation numbers, of all the atoms in a neutral molecule, neutral molecule is equal to 0. Sum of oxidation numbers of all the elements in a neutral molecule is equal to 0. If we know these basic ideas, we can usually calculate the oxidation numbers of the various elements. I repeat, oxidation number is the net positive or negative charge on one atom of the element in its combined form. Oxidation number in the elemental state is equal to 0. For example, sodium metal is equal to 0, calcium metal is equal to 0, aluminum metal is equal to 0, Cl2 chlorine gas is equal to 0, H2 gas is equal to 0, N2 gas is equal to 0. So in the elemental state, oxidation number of an element is equal to 0. Now, oxidation number of an ion is equal to charge on the ion. For example, Na plus ion, charge +1. So oxidation number is equal to +1. We call it as positive oxidation state. With a chloride, Cl minus, the charge is equal to -1. And therefore, oxidation number is equal to -1. We say it is in the negative oxidation state. And we must know the oxidation numbers of some elements like hydrogen, oxygen, alkali metals, then halogens, etc. In the compounds. In the compounds, oxidation number of hydrogen plus 1, oxidation number of oxygen minus 2 in the compounds, not in the elemental state. Then alkali metals, sodium, potassium, etc. plus 1, alkali earth metals, calcium, magnesium, etc. plus 2, halogens, fluorine, chlorine, bromine, etc. is equal to minus 1. Then sum of the oxidation numbers of all the elements, all the atoms in an ion is equal to charge on the ion. And finally, sum of the oxidation numbers of all the atoms in a neutral molecule is equal to 0. So if we know these basic ideas, we can calculate the oxidation numbers. So let us try to find out the oxidation numbers of some of the elements. Examples, say 1. MnO2, manganese dioxide. And you are asked to find out the oxidation number of manganese Mn. Oxidation number of manganese in MnO2, manganese dioxide. We have to calculate the oxidation number. Okay, so oxidation number of manganese is equal to X. You call it as X. So we have to find out X. X. Now you find out the sum of the oxidation numbers of all the elements present in MnO2. Oxidation number of manganese is equal to X. There is only one manganese atom. So X into 1. We are going to take the sum of the oxidation numbers of all the atoms. Sum of the oxidation numbers of all the atoms. Oxidation number of manganese is equal to X. There is only one manganese. So X into 1. Plus oxidation number of oxygen in its compounds is equal to minus 2. We have 2 oxygen atoms here. So into 2, you take the sum. This is the sum of oxidation numbers of all the atoms. And this is equal to 0 because MnO2 is a neutral molecule. So that is equal to 0. Now we can easily find out X. So X into 1 is equal to X. Then minus 2 into 2, that is equal to minus 4, is equal to 0. Therefore, X is equal to, you say the value, you find out the value. What is the oxidation number of manganese? What will be your value? You say?
4.
4? No. No. What is oxidation number? The net positive or negative charge. Charge. So plus charge or minus charge. So you must say plus 4. Not simply 4, it is plus 4. 4 is plus 4 in our mathematics, arithmetic, but I agree. But when you give the oxidation numbers, you must say whether it is plus or minus, positive or negative. It is compulsory. So it is a plus 4. Okay. Now take another example. Say example 2. KMnO4. Say KMnO4. Example 2, KMnO4. The name of this compound is potassium permanganate. Potassium permanganate. And you are asked to find out the oxidation number of manganese. Manganese in KMnO4. Okay, as before, oxidation number of a manganese is equal to X. You call it as X. Now you calculate the sum of the oxidation numbers. Potassium, alkali metal. You know, oxidation number of a alkali metal, sodium, potassium, etc. in its compounds that is equal to +1. So potassium +1. There is only one potassium. So +1 into 1. Plus manganese, oxidation number X. Only one manganese. So X into 1. Plus oxidation number of oxygen in its compounds, normally -2 into 4. The sum is equal to KMnO4. It's a neutral molecule. So the sum is equal to 0. It's equal to 0. Now you find out the value. +1 into 1. +1. Then plus X into 1. X. Then -2 into 4. -8 is equal to 0. Therefore, X is equal to 0. You take -8 to right side. It is +8. +1 to right side. -1. And this is equal to Achut. What is the value? X is equal to
+7.
it is +7. Please don't say 7. It is +7. Okay? It is +7. Let us take another example. Potassium dichromate. Third one. K2 Cr2 O7. The compound is potassium dichromate. Potassium dichromate. You have to find out the oxidation number of chromium. As before, oxidation number of a chromium is equal to X. Let it be X. Now you find out the sum of the oxidation numbers of all the atoms. Potassium, alkali metal, oxidation number group 1, oxidation number is equal to +1. There are 2 potassium atoms. So into 2, you take the sum plus chromium, oxidation number is equal to X. There are 2 chromium atoms. So X into 2 plus oxygen -2 into 7. And the sum is equal to 0.
0.
It's equal to 0. So +1 into 2 +2. Then plus X into 2, 2X -2 into 7 -14 is equal to 0. Therefore, 2X is equal to 0 plus 14 -2 is equal to +12. Therefore, X is equal to +12 by 2 is equal to +6. Okay. To take another example, next one. CrO4 -2, the fourth one. CrO4 -2, and it is the chromate ion. Chromate ion, CrO4 -2. You have to find out the oxidation number of chromium. Oxidation number of chromium is equal to X. You take the sum. Chromium X into 1, only 1 chromium, plus oxygen -2 into 4 is equal to, the sum is equal to, it is an ion, It is an ion. So the sum of the oxidation numbers is equal to the charge on the ion. It is a -2. -2. Is equal to -2, not 0. It is not 0. -2. So x into 1, x -2 into 4, -8 is equal to -2. Therefore, x is equal to -2 plus 8 is equal to +6. +6. So now you have got some idea regarding the calculation. Okay. You take the fifth one, MnO4 minus. This is permanganate ion. Permanganate ion. There is charge. Permanganate ion. Find out the oxidation number of manganese. So oxidation number of manganese is equal to X. Now you take the sum. Manganese X into 1 plus oxygen -2 into 4. The sum is equal to, it's an ion. Charge on the ion. Minus means -1. -1. So X -8 is equal to -1. Therefore, X is equal to -1 plus 8 is equal to +7. +7. If you are missing plus, the answer goes wrong. +7. Now you have got an idea? Some more examples are given to you in the notes. You just go through the notes and try to find out the values of oxidation numbers of the other elements. Some examples are given. Okay. So let me stop now. So it is time. Oh, the others have already come there. Let me stop.